So for the next part of the range cylinder and range shifting issue, I managed to remove the cylinder housing, or the cylinder itself, the range cylinder, and there's the range piston. And I actually managed to remove that seized bolt that I had there. I threw some ATF, automatic transmission fluid, on it. I don't know if that made a difference or not. And then I used vice grips or vice pliers, and I was able to get it off. So this is what it looks like in the field, on the truck. So for the first part, the first thing that I should say is, when you're playing with this thing here, you got to be very, very careful to make sure that there's no air inside this thing here, inside the cylinder. There's no air. Make sure that air is drained. Pretty easy. You just disconnect the fittings from here, and that'll allow the air to escape. That's the most that's the most sure method. Same for the cap here. Now they're completely disconnected, independent of each other, so just because you removed air from one doesn't mean you removed air from the other. So basically what I'm saying is, when both fittings are disconnected, there's 100% no air inside the system. I mean, something I guess could clog that, get that plugged. It's possible, but I think it's only possible somebody did that on purpose. But you have to have, like I said, make sure this is disconnected. Now for me, it was not easy getting this thing off, and I had to have a bit of a special procedure. So on the Eaton manual, it just says remove the nut and then remove cylinder, remove the piston nut, remove piston, and then remove cylinder. So it makes it seem like it's that easy. And if you have stainless bolts with anti-seize on them, then it is that simple. But in my case, like just look at that there. That's because I cleaned it up a bit. So this thing was rusted in there, and it took me a good day or maybe more to get it out. So what I had to do is I had to put air on this side so that the whole piston came out as far out as possible. And then I loosened the nut, but again, I actually had air in this. So if I loosened the nut with air in this whole thing will just fly off at me, or just fly off and hit something. So like when I tested it, I put 120 psi of pressure. PSI means pounds per square inch. So what do we have here? We have, I'd say maybe about 5 square inches here at least. So 120 psi per square inch. If you've got 5 square inches, that's about 5 times 120. That's about 600 psi. Or sorry, that's about 600 pounds of force on this thing. So if it does fly off at you, it's gonna hurt, or it's gonna damage it. Like if it doesn't hit you, it's gonna damage it. So I made sure not to loosen the nut all the way, not to remove it. I just left it. And then at one point it wouldn't come off completely, so at one point I just loosened the nut. I put this piece of wood on underneath, and while I was not in the truck, I slowly opened the air valve to allow just a little bit of pressure, just enough to push the cylinder out, and sure enough, it just fell off. So yeah, just be very careful with air, pressurized air systems here. That's what I should say. Or you shouldn't do it at all. Just watch me do it, and you don't do it. Yeah, it's probably the best advice to give you here. But I mean, again, you just gotta, in mechanics with old trucks, older vehicles, you just gotta be reasonable. You don't need stupid computers. You don't have any stupid software. You just gotta have a reasonable brain. You just gotta have a small brain at least. Alright, so the bore on these things on it looks very nice. Nice and clean. Again, the piston and even the O-ring, which I suspected would be damaged, it looks pretty fine. And when I had the cap off, it would shift, so that kind of told me that the piston was not a problem. But since I was already 90% of the way there in removing this thing, I just said, well, hell, why not just remove it and apply some lubricant to the O-rings. Which, by the way, you need to have special lubricant. You can't use any mineral oils. You can't use any normal oils like gear oil, ATF. You can't use any of that because it'll react with the rubber and destroy it. So what you can use is brake fluid. Brake fluid it's one of the oils that's in contact with rubber and seals. So if you think of it, all the other oils have little to no contact with seals. But anyways, it's different rubber anyways. So to be safe, you have to, the manual says you need to use silicone lubricant. Now, in most cases, dielectric lubricant or dielectric grease is made of silicone grease. So usually dielectric grease works just as well. But so you can use dielectric grease, silicone lubricant, or brake fluid. So brake fluid does not attack rubber. It's safe for rubber. I'll show you just in a second what I used, or what I'm gonna use. I'm gonna use this shit here. Pretty expensive. $23 for a 36 milliliter. But I mean, this will last me a lifetime. So it's actually silicone ceramic brake lubricant. I was a bit afraid of the ceramic part. I thought, well, maybe it actually causes friction, but the ceramic actually reduces friction. And over here in the back, it says, as soon as it decides to zoom in, come on. There we go. Compatible with all rubber and plastics. Look, silicone formula. High concentration ceramic solids. But anyways, it says it's compatible with all rubber and plastics. So that's pretty much what I want to hear. Again, I use this at your own risk. I'm just showing you guys what I'm using, what I'm going to use. So moving on from my procedure, once I was able to get, so first of all, the nut on the end here, the piston nut, it does require quite a bit of force to remove. I think, I'm just trying to remember here off the top of my head, I think it's 70 foot-pound. It's a hell of a lot of force. So if you're using like a regular ratchet like this with a half-inch drive, I think it is, or 3/8. Anyways, if you're using that regular ratchet, you probably won't be able to remove it. It might damage the ratchet. So I actually I had to use a big ratchet, a bigger ratchet with a bigger drive to remove it. Wasn't too hard with the proper tool. And then I applied air to get this thing out, like I said before. And then this thing, I still had the stupid broken bolt in there, so that kind of made it a bit harder because it was kind of seized in there. But I tapped it out with the hammer. I spent a good time and with the sledgehammer, and I tapped it out. And at one point I just pulled it out and it came out. And that's pretty much how it goes. It just slides out. I'll show you where the seals are located. So there's basically, or the O-ring, there's an O-ring inside there. And as you can see, there's oil on the rear side, but no oil on this side. So that rear side is actually exposed to the transmission. So that probably there is probably gear oil. I'm not sure how the gear oil doesn't damage that O-ring, but this seems okay. There's no gear oil in here. So if that O-ring was bad, we'd either have some gear oil in here or air from here, instead of, you know, staying here where it's supposed to, but actually go past that O-ring and into the transmission, and it would pressurize the whole transmission to the point where if you were to remove a bolt or remove the transmission shifter or one of the bolts from the shifter, like I did for adding oil, you'd get a bunch of air just escaping from there. Now this thing was made in 1985 and it's still like new, no problems at all with it. So I heard that there's newer models of cylinders and they're aluminum. Can you believe that? So they're just coming out with all sorts of crap. And I've seen a video where a guy has an aluminum and it's all scratched and screwed up in here. You can't beat cast iron. It's very hard. It's very hard to scratch. It's very durable. Aluminum has no place in a vehicle. Maybe on an airplane, not in a vehicle. Much less a truck. This is the part that's lasted for so many years. For what, 30 years? Over 30 years. You can't bend it, you can't scratch it. It's pretty indestructible. Aluminum, on the other hand. Anyways, moving forward, we've got another big O-ring here and another little O-ring on the middle there, and the shaft goes through it. So that's pretty much, I'm not going to go into detail how this works. I'm not going to do a video because there's already another video on YouTube from a guy that showed this here. I forget his name. So I'm not going to do it. But with this out of the way, I can actually grab the grab the shaft from the piston where this was on, and I can move it back and forward. See, I mean, it was moving, but I just like to test it that way by hand. But I can actually look inside the transmission from, like, it's a pretty big hole, as you can see. The other thing that I find interesting here is that it's got this steel gasket. I think it's steel, maybe aluminum, I don't know, but it does have a gasket there, even though this looks like it's part of the cylinder here. This is actually a gasket here, but just leave it. It's nice and tight in there. I'll get this out of the way and I'll try to take a look inside the transmission. Right, so there's the big hole there. I did clean those up. The ends of the hoses here. These hoses have swivel joints on the hose itself, but they're pretty stiff. I can't move them by hand. But I much prefer having the fitting instead of having the swivel on the hose itself. Anyways, I don't know if we can. I might have to do it in a separate video. Yeah, I don't think I can get flash. I have to do a separate video for flash, I think. Alright, so pretty much I'll end the video here. But I'll just see if I can. So I have to do it with one hand. I'll see. I'll do it. Okay, I'll show you guys what it looks like inside on the next video.